In these notes, we're going to go through 2 more ways to prove that triangles are congruent. So first we need to go through a few definitions. The first one is an included angle. And an included angle is, if you notice the pencils right here, that these are 2 sides in a triangle. And the included angle is the one that is between the 2 sides. So when we are proving triangles are congruent by side angle side, so SAS is what that stands for, so side angle side, that's when we have, if we have 2 sides and the included angle of one triangle are congruent to 2 sides and the included angle of a second triangle, then the 2 triangles are congruent. So the angle has to be between the 2 sides is the biggest part. So in our pictures on the right over here, you can see that if we have side RS, that is congruent to side UV, and then angle R is congruent to angle U, and RT is congruent to UW. Then you notice that we have a side, so side, our angle, and then our side. We have a side, angle, and then our side are all paired up the same way that we have our 2 triangles are congruent. So remember, our letters do matter, so R is first, and that's congruent with our U. S is next, so that's going to the side that has 2 slashes on it, so 2 slashes, so V would be next. And then T is the last one, and so W would be our last one on the other triangle. Just like I did on the other notes, I'm going to go through an actual 2-column proof of what side angle side is, so you can recognize it when we practice these in class. So side angle side. So first we need to write our given statements in our picture. So most of these are already done. So BC is congruent to AD, and BC is parallel, that's what our little triangles mean, to side AD. So if you notice, those are the 2 given statements, so go ahead and copy those down in these 2 lines. And the given statements could be mixed around, but I usually put them as the first statements. So next, why do you think that we can say that angle BCA, so that's this angle right here, is congruent to angle DAC, so this angle right here? And if you notice, we're using the parallel lines, so this one's going to come up pretty often, and you're going to see one like this in class as well. But we've got a parallel line, we have a transversal going through it, and now what's the name of those 2 angles? And those are alternate interior angles. So that's the reason we're going to put with why those 2 angles are congruent. So next we have a little hint, the reflexive property. Remember, that's where it's congruent to itself. So that's going to have to be the side that they share. So that's going to be AC. And now you can see, I'm going to redraw this because I've got too many extra pieces in there. We have a congruent side, another congruent side, and we have a congruent angle. So you have to notice where those angles and sides are. So we can see that in the first triangle we have a side, we have an angle, and we have a side. The other one we have a side, or a side, an angle, and another side in the same order, with the same congruent pieces. So we can say that these 2 triangles are congruent by side, angle, side. And I know the way to write my triangle congruent statement from right there. So then I just copy that statement here, but then my reason is my side, angle, side congruence postulate. So remember, I said that there's 2 congruence postulates that we're going to learn in this video. So the second one is HL, which before we get to that, we need to remember a few things about right triangles. So we remember that there are 2 legs and in our right triangle and 1 hypotenuse. So when we are seeing HL, HL stands for hypotenuse leg. So if you notice leg, we have 2 legs possible, so we have to make sure they're the same leg in both of the triangles. So our definition is if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of a second right triangle, then the two triangles are congruent. So when we're looking at our pictures over here on the right, we go through listing out what is congruent. We have, if both triangles are right triangles, you have to make sure that they're right triangles, otherwise we don't have hypotenuses or legs. Then we can see that AC is congruent to DF, which is the leg, so we've got an L. And then we have AB is congruent to DE. And if you notice, that's the hypotenuse, and that's because it's across from our right angle. Then we know that the two triangles are congruent. So we have to pair up the sides again. So our angles. So angle A is between the 1 and the 2. So angle D is our first one. Then B is the other angle that's not a right angle, so the side that makes our hypotenuse. That'd be our angle E. And then letter C is our right angle, so F has to be the last letter. So for our proof of using HL, so remember when you start a proof, you may not know the reason that it's going to be at the end, but we're going to go through one of each of them. So in our triangles over on the right, we don't really have all of the different pieces that are labeled. So AC is congruent to EC. And if you notice, we have 1, 2, 3, 4 statements for the given, and that's where the 4 are going to go right here. All right, so going through each of these, we have one side. Make that a different color. So we have one S already, or that really could be, if you look at it, that could be one of the hypotenuses. So that's probably our hypotenuse. We have that AB is, there we go, perpendicular to side BC. And because of that specifically, we know that this is going to be a right triangle, a right angle. And that comes down to step 5 right here. So definition of perpendicular lines means that those are going to be right angles. And because those two triangles have a right angle, we have right triangles. And the reason for that is because the definition of a right triangle. So in our picture, right now we have one hypotenuse, and that's it. We've just shown that it's a right triangle and that we have a hypotenuse, so we're still missing a leg. So if you remember from up here, it says that AC is a bisector. So AC right here bisects segment BD. So that means that BD is the one that's being bisected into congruent pieces. So we can say that BC is congruent to CD, so segment CD, and it's the definition of a segment bisector. And now we have our hypotenuse and we have our leg, and we've already shown it is a right triangle. So now we can write our proof statement, which remember is right up here. So triangle ABC is congruent to triangle EDC. And our reason, if we notice, we want to look at our two triangles, we can see our hypotenuse and we can see the leg of a right triangle, so it's the HL congruence postulate. So on these questions is where we are going to just determine which type of triangle we have, and then also determine if we can say it is congruent by one of the two methods we're talking about in this video, or it could be in either. So for the first one, we notice it is a right triangle, and remember we always want to notice that they have a side that is shared, so, and that's by the reflexive property, and it has this other side that is on here. And if you notice, we have an angle, a side, and then a side, or a side angle, but if you spell that out, that would not be a pleasant word, because you would have ASS, and we are not going to have a congruent statement that starts out that way, or SSA, because it's really the same thing. So it's not going to happen like that. So, but we do notice that it is a right triangle, so we know that this will be HL because we have our hypotenuse and we have our leg. For the next one, they do share the side in the middle because of the reflexive reason again. But if you notice in the triangle below, it has an angle and it has all three sides. That could be side, side, side from previously, but the top triangle only has two things that are congruent, so one angle on one side, and that's not enough information ever in any of our triangles to figure anything out. So this is going to be a none or neither. So they're not congruent. For the last one, you have to remember that this is a circle, and also these opposite angles right there are going to be congruent because those are vertical angles. From before, remember vertical angles are congruent, but it's a circle, and if this M is the center, then we know that all these sides are going to be congruent to each other because it's the radius of the circle. So the radius of the circle is going to be congruent. So then we do have a side, an angle, and our angle is between the two sides. So we would have side, angle, side for why these two triangles are congruent. For 4 and 5, we're going to be playing an activity in a few days on doing the same thing. So we have to state the third congruence that's missing, basically, to prove that our two triangles are congruent by the given postulate. So this first one is by side, angle, side. So we need to make sure that our angle is between the two sides. So first, let's draw everything in our picture. So JR is congruent to DF. JM, so we're going to do a different congruent symbol, is congruent to DM. And we need the angle to be between the two sides. So the only place that would happen is if it was angle J and angle D is what we are missing for them to be congruent. For number 5 now, we first start out that J is a right angle, and J is congruent to D, so that means that D also has to be a right angle. And let me give you one other congruent statement that is missing, or that you should be given. We're going to say that JM is congruent to DB. So this is given to you, not what you're trying to find. So JM is congruent to DB. So you need to figure out if it's HL what we are missing. So remember, we need one hypotenuse and one leg, and right now this is the leg. And so you will need the hypotenuse.